Hello, Math 30-1. Today we're going to be looking at radical functions and what do radical graphs look like. So to start off here, we're just going to analyze the square root of x. Okay? So if I look, the square root of -4 is, well, that's not defined, so there is no answer there. Square root of -1, we can't square root of negative gain, so that's not defined. And then we have square root of 0 is going to be equal to 0. Square root of 1 is 1, square root of 4 is 2, square root of 3, or square root of 9 is 3, and square root of 16 is going to be 4. Now let's try and graph this here. So we start when x is 0, y is 0, when x is 1, y is 1. When x is 4, y is 2. When x is 3, y is 9. Or sorry, when x is 9, y is 3. And then when x is 16, y is 4. So now we're just going to quickly draw that out, and we're going to get something that looks like that. Okay? So now it says explain why the domain of the function y is equal to the root of x is not the set of all real numbers. Well, this is because we cannot square root a negative. Of a negative. So we can't take the square root of a negative. So state the domain of the function y is equal to square root of x. So my domain, I'm going to write it in two ways here. So my domain is equal to x such that x is greater than or equal to 0. Or we could write it like this. Our domain is equal to, and we have 0, and x goes on forever. 0 is my minimum, and we have an infinite maximum. Now I want to state the range of this function as well. We're looking at this. We can't go below 0. So then, same thing here. My range is equal to, we're going to look at y such that y must be greater than or equal to 0. And y is an element of all real numbers. I forgot that for the x. That's okay. And we know my range is also, well, my minimum value is 0, and it goes on forever in the positive. Okay, so now let's take a look at my first example here. So my first example says, in each case we're going to describe the transformations that's happening to the graph y is equal to the square root of x. Okay, so part 1. What's happening here? Well, if we remember, we have to follow my order, which is stinky rotten tomatoes. So S, R, T, which is stretches, reflections, then translations. So I look at this here. We have absolutely no stretches. I have no reflections. All I have is translations. Y goes to y subtract 4. Okay? That's the same thing as shifting 4 up. So we translate. We have a translation of 4 units up. Okay? Now, we have x goes to x plus 2. Now this means we have a translation of 2 units to the left. Okay, now part 2 says make a rough sketch. So I went 4 units up and 2 units to the left. So this is going to be 4, -2, and my graph is going to look something like that. Okay, now it wants to know what is my domain of the function, and then it wants to know what is my range of the function. So my domain is going to be equal to, we have x such that x must be, if we look at this here, greater than or equal to 2, because it's from -2, where x is an element of all real numbers. Okay, And we could also write that like this, so we could also put it this way. We're going to have -2, comma, and it goes on forever that way, infinite. Now let's take a look at my range. I'll look at this here. We're starting here, and it always goes up, so it has to be bigger than 4. So we're going to look at my y values such that y is greater than or equal to 4, and y is an element of all real numbers. And that, or we could say in our other form, like this, we could have 4, and we're going infinitely big that way. Okay? And if you want, you could punch this into your calculator and check to see if we have more or less the same thing. Let's take a look at B here. Alright, so now, once again, we have to look at my stretches first, my reflections, then translations. So just remember, stinky rotten tomatoes. I first look at this. Are there any stretches? Yep. I have y is replaced with 2y. So that means we have a stretch. So we have a vertical stretch by a factor of 1 over 2. Okay, so if we put it to that side, we have 1 over 2 would be there. Okay, now what else happens here? We have no other stretches, but we have a reflection. Okay, so we know x is replaced with -x. So in this case, I have a reflection in the y-axis. Okay? So what does that look at? This one here is going to look something like this. Maybe a little bit smaller there. But so basically this should be something like that. So it doesn't quite go as high as that. It's a bit smaller. It's narrower. And it's half as high. So this point should be half as high as the point on that side and so on. And it's going to be reflected that way. So now what is my domain and range? My domain, we are going to look at x such that x must be now less than or equal to 0, where x is an element of all real numbers. Okay, so in other words, when we do that, we're going to have infinite. We go -infinite that way. There's a little negative sign there. All the way to from 0 that way. And it could equal to 0, so we put the closed brackets. Now let's take a look at my range. We're going to have y such that, now same thing here, y can be greater than 0, y must be greater than or equal to 0, y is an element of all real numbers, okay? And in this case, we have closed brackets because it can equal to 0, and it goes on forever infinitely that way. Alright, now let's take a look at C. So, once again, we have to look at stretches first, stinky, rotten tomatoes, stretches, reflections, translations. So I look at stretches, there's no stretches. Okay, reflections, in this case, y got replaced with, because this really belongs on this side, y got replaced with -y. So that means we have a reflection in the x-axis. Alright, now we look at here. What else happens? Is there no more reflections in the y? So now we have our translation. So I know y is replaced with y plus 5. So with this gives me a translation of 5 units down. Okay, so basically if I was to redraw this, I know first I have a reflection, and then we're translated 5 units down, so it's going to look like that. Now, we're going to now look at my domain and range. So my domain, we're looking at x such that we have x is greater than or equal to 0. And x is an element of all real numbers. And we are going to write it the other way as well. So we have 0, comma, and infinite, which is open, because it could equal to 0. Now let's take a look at my range. We are going to look at y such that, right here, y actually starts at -5. So we have y must be less than or equal to -5. Y is an element of all real numbers. Okay. Now here, we could go forever in the negative. We're going forever down, so we have negative infinite. And we start, our max is -5, so that's closed. Okay? Last one is D. So once again, let's write out, we have stinky, rotten, and tomatoes. So which one happens first is the stinky, so stretches. Well, first of all, I'm going to put that 3 there. That's the same thing as saying y was 1/3y. Okay? So that means I have a vertical stretch by a factor of 3. Okay, about the x-axis. Now we have x got replaced with 2x. Okay, this means I have a horizontal stretch by a factor of 1/2. Now, if I look, so we're done my stretches. Are there any reflections? Nope, there's no negatives. So now I want to look at my translations. But before I get to my translations, I'm going to simplify this here. So this is the same as root 3√2, and this is x minus 1/2. Okay? I have to factor out that 2 from my equation. So now I know what my horizontal translation is. So basically here, x is turned into x minus 1/2, is replaced with x minus 1/2. So this is a translation of 1/2 units right. Okay, so let's draw this now. So we're going to start over here. This is going to be 1/2, and it's going to be looking something like that. Okay, so let's take a look at this. Let's put my domain is equal to, we're looking at x such that x must be, well, we're starting at 1/2 here, greater than or equal to 1/2, where x is an element of all real numbers. Okay, so we have this again. We're going to put 1/2 is my minimum, and it could equal it, so it's a square bracket, and it's all the way to an infinity, and we don't know where that ends, so it approaches forever, so that's why that's a circular bracket. Now let's look at my range. We're looking at y such that, now here, y must be greater than 0. It's greater than or equal to 0. Y is an element of all real numbers. So once again, we look at this here. It could equal to 0, so it's a square bracket, and it goes on infinitely, so it's a round bracket. Okay. So now we're going to look at question number 2. It says, determine the domain and range of this function given the following restrictions. So here it's saying a is greater than 0 and b is greater than 0. So my domain for this, when a is positive, is always going to be, we're going to look at x such that x is greater than or equal to 0, and x is an element of all real numbers. Okay, and we're going to have my range, looking at y such that y is greater than and equal to 0, and y is an element of all real numbers. So this is just for every time they are both positive, because if I look at this, there's absolutely no reflections. Now here we have a is less than 0. So if a is less than 0, that means a is outside. We have a reflection in my x-axis, so my graph is going to look like that instead. Now that doesn't affect the domain, but it really affects the range. So we look at this here. My domain is the same as the question before, as in part A. We're going to have x such that x is greater than or equal to 0, and x is an element of all real numbers. And my range, we're going to look at this way. We're going to look at y such that we have y must be less than or equal to 0, and y is an element of all real numbers. Okay, so now we're going to look at C. Okay, so this one here is saying A is greater than 0, so my A is positive, but my B is negative. So if I look at that, my B is negative, we have a reflection in the y-axis. So this one's going to look something like this. Okay, so if I look at that, we have a reflection in my y-axis. It's going to look there. So once again here, I'll look at my domain first. So my domain is going to be, it's relating to the b's, x, we're going to have x such that x is less than or equal to 0, and x is an element of all real numbers. Okay, I'm going to write this one in the other way as well. So if I look at that here, it's going to be an open bracket because we have negative infinite this way. It goes forever that way, so it's negative infinite. And we have 0, we know it could equal to 0 is my maximum. Okay? So we could either write that or that way. Now let's take a look at my range. My range, everything's going to be positive. So we're looking at y such that y is greater than or equal to 0, and y is an element of all real numbers. Or we could put it like this. We know its minimum is 0, and its maximum goes on forever. So that's just going to be infinite. And we have the circular bracket. Last one. Now this one says we have A and B are both negative. So that means we have reflection in the y and x axis. So my graph is going to look something like this here. Okay? Because we reflect in the y and x axis. So in this case here, my domain is going to be, we look at it, we're going to have x such that x is less than or equal to 0, and x is an element of all real numbers. And we're going to have my range, we're looking at y such that y is less than or equal to 0, and y is an element of all real numbers. Okay? If I want to put this in the other form, it would be my domain is equal to, we have open brackets because we go forever on the negative, we don't know the ending, and we have 0 closed. I'm going to look at my range, and it's the same thing, forever negative, and we have a 0 closed.